response to the use of medicines, bacteria, not humans or animals, become antibiotic resistant. Bacteria have been evolving and developing since the beginning of life. Doctors and researchers have been well aware of the looming possibility that antibiotics would fail since the development of antibiotics in the 1960s. I assume that everyone in this room has at one point in their life needed the use of antibiotics to treat some kind of infection or illness that they were dealing with. I myself completed an antibiotic cycle just last week and started to think about this problem and started to do research about the longevity that we have left for antibiotics. So today I'm going to be talking about, one, how bacteria become resistant, the alternative forms of treatment that are currently being developed, and how we can stop furthering the spreading. So with that, let's get into how bacteria become resistant. In a Guy Rideau article, How Bacteria Become Resistant, he explains that bacteria are constantly evolving and can modify their structure to develop resistant tendencies. When bacteria encounter an antibiotic, they can take that material and change their genetic makeup to develop resistance to the bacteria. So imagine that you have a bacterial infection. You have lots of bacteria in your body, both good and bad. When you start taking an antibiotic for the infection that you have, you may already have drug-resistant bacteria in your system. So now, taking the antibiotic, your body is able to kill off the infected bacteria, but the drug-resistant bacteria are left. So now with all other bacteria gone, the drug-resistant bacteria can flourish. So the simple answer seems, well, we should just develop new antibiotics, right? That's actually harder than it seems. Martin Lieb explains in his article, A Shot in the Arm, the issues with developing new antibiotics. Until 10 years ago, all major drug companies were investing in antibiotic research. But today, these programs have been drastically pruned, and many have been cut altogether to pursue more lucrative areas of chronic illness and mood disorder. Even though this article was published in 2004, this is still an issue that's happening today, with companies opting for financial appealing illnesses instead of antibiotic production. In the same article, Lieb states that the catch is that the more an antibiotic is used, the more resistance to it spreads, forcing doctors to try other antibiotics. So now, even drugs that once served as a last resort are losing their potency. So you must be thinking, well then, we should all stop taking antibiotics, right? And even though that can seem like the answer, it's not. So let's get into the alternate forms of treatment. With doctors and researchers all agreeing that the development of new antibiotics is the best option, companies are starting to go into that field, but that's easier said than done. With big companies opting for alternate forms of development, it's forcing smaller companies to do most of the heavy lifting when it comes to developing an antibiotic. Even though they're leaving only the small companies to do research, there has been progress made in the development of new antibiotics, which we can see from Teixobactin. In an article titled Bacteria Assessing Resistance to New Antibiotics, Michael Hochberg and Gunther Janssen introduced our new antibiotic molecule, Teixobactin. Currently, though, there are no bacteria that are showing resistance to Teixobactin, which is a really good sign, but there is much more research to be done before Teixobactin can hit the market. Another form of treatment that is in the developmental process is bacteriophages, which are also known as killer viruses. Their name comes from the ability to kill off infected bacteria. Bacteriophages are, simply put, viruses that infect other bacteria and therefore are able to destroy them. They're found in soil, seawater, food, basically everywhere. So even though this isn't a new idea, it has only recently become plausible because of advancements made in DNA sequencing. In an article by Scott Laffey and Heather Bunchman, they detail the process of bacteriophages. They explain that doctors are now able to identify which bacteriophages are the right fit for a virus and are able to cultivate and purify the bacteriophage to be injected into the body to fight off the infection. They are currently only being used as a last resort option, though, because of the severity that it takes to purify the phages, but there have so far been a few successful cases. So with most of the alternative forms of treatment still being in developmental stages and with other ones being pretty severe, we are still currently relying on antibiotics that we have now, and we must strengthen their effectiveness. So how can we as individuals help this? The main form of prevention is to slow the resistance spreading. The European Commission developed an action plan recently, and it was detailed in a News RX Health and Science article that was titled "Last Line Antibiotics Are Failing." In this detailed action plan by the EU, they explain how they are now creating activities promoting prudent use of antibiotics that are organized in more than 40 countries across the European region. These activities occurred during the week of November 18th, and they were started in 2016 to mark European Antibiotic Awareness Day. The ECDC works jointly with the World Health Organization in Europe and partners on World Antibiotic Awareness Week. The EU, though, is not the only one that is developing an action plan for this problem. The CDC recently developed their own form of a global prevention plan, which is detailed on their website under antibiotic and antimicrobial resistance. Rather than being a full, detailed plan with steps, the CDC lists ways that they are helping to aid in the global prevention. Some of these ways are enhancing laboratory capacity to detect and report resistance that have global health implications, implementing programs in healthcare settings to prevent the spread of disease, and supporting a national network of travel clinics to better understand the resistance across the United States and to ultimately improve the health of international travelers. But still, these action plans are not the main method of controlling resistance. In a Life Science article by Rachel Retner, she explains the containment strategy. The containment strategy is a four-step process, starting with 1, identifying the antibiotic-resistant germs at a given facility, 2, assessing the facility for gaps in infection control, and 3, screening other patients to see if any are silent carriers of infection. Finally, they coordinate a response with other facilities in the area to transfer any patients that may have been affected. Now, these are all big picture things, so what can we do as individuals to help stop this problem? So, in an article entitled Antibiotic-Resistant Bacteria by Department of Health and Human Services, they list 4 things that we as individuals can do. 1, we can help to minimize the unnecessary prescription and overprescription of antibiotics. So when you go to the doctor for a common cold, don't ask for antibiotics. Antibiotics are specifically reserved for bacteria, not viruses. 2, make sure to complete the entire course of a prescribed antibiotic, because if you stop taking the antibiotic when you start to feel better, you may still have some of those resistant bacteria in your body, and they can start to multiply after you've stopped taking the antibiotic. 3, practicing good hygiene. Making sure to participate in good hygiene helps to prevent you from contracting a bacterial infection in the first place, and also helps to reduce the risk of bacteria infection for other people. 4, strengthening your immune system by consuming a diet of mostly healthy foods. So now that I've covered my 3 main points, let's review. So today we covered how bacteria become resistant, the alternate forms of treatment that are available, and what we can do as individuals. As we head into the future, doctors and researchers are working to develop forms of treatment that are not currently being used, but they are helping to stop furthering the resistance and also learning how to treat the currently resistant bacteria. But with these development process being so extensive and with so much approval and testing being needed before they can actually hit the market, we are left to stop the resistance on our own by working to make sure that we are not furthering the resistance ourselves. So it's really important to inform others of the problem and stay educated yourself when making decisions on how to stay resistant to bacteria.